or 10-foot ladder is placed against a vertical wall, right? So let's assume we have a vertical wall here, and then let's assume the 10-foot ladder is placed maybe something like that. Okay, let's assume this is the ground over here. Okay, from the bottom of the ladder to all the way up to wall, let's say it's smooth like that. Okay, so a 10-foot ladder, so this is our ladder. Okay, let me color the ladder by blue one. So let's say assume this is our ladder. All right, and what is the question? Oh, the length is 10 foot, so maybe we can also write down that information over here. Suppose the bottom of the ladder, okay, suppose the bottom of the ladder, which is here, right, slides away from the wall. Let's say somebody is pulling the bottom of the ladder, and then it's actually moving away from the right wall and okay, that's the case. But what is given over here? Suppose the bottom of the ladder slides away from the wall at a constant rate. Okay, nice. But at a constant rate of 4 feet per second. How can we write down this information mathematically? What does it mean by rate? Derivative, right? But derivative of the what? On this case, if we assume the distance from the bottom of the ladder all the way up to the, let's say, bottom of this wall or something like that, right? If that is x, then actually derivative of x with respect to t, you can see that if it slides away from the wall, so this length is the distance from the bottom of the ladder to the bottom of this wall will be gradually increasing, right? So on that case, the derivative of x with respect to t will be 4 feet, right? So this is the information we can extract from that second sentence. Okay, until now we don't know what is the question, so let's read the question. It says that how fast is the top of the ladder, which is here, right? How fast, so again something to do with the rate or speed, right? So how fast is the top of the ladder is sliding down. So when somebody is pulling here, and then the bottom of the ladder is moving away from the wall, so this will be just kind of sliding down, right? So the question is, how fast is the top of the ladder sliding down the wall when the, okay, how, let me first write down this information here. How fast is the top of the ladder sliding the wall? Okay, so how can we write down that information in a mathematical form? Again, like what we have done over here at the bottom, if that was x, derivative of x with respect to t is 4, right? In the similar way, if we assume the distance from the top of the ladder to the, let's say here, all the way up to the bottom of the wall, if that is y, right, then actually our goal, it looks like, it's a how fast is the top of the ladder sliding down the wall, right? So that means what is the derivative of y with respect to t? So this is what we need to figure out, but not always. It's a when the bottom is 8 feet from the wall. What is the bottom here? The distance from the bottom of the wall to the here, the bottom of the wall is actually denoted by x, right? So if that is the case, we just need to figure out this when x is equal to 8. Okay, first of all, pause this video for a moment and think about it if you understand this, or if you don't understand, again try to repeat this video, okay, and then again come back over here and then think about it if you don't, if did you get this information or not. All right, so if you get this one, so I can write down the summary of all of these information. So what did we obtain? We have two variable here, x and y, right? And then we also know what is the length of the ladder, okay, that is 10, right? Okay, so which is over here, right? And then that is fixed now, right? And we also have given derivative of x with respect to t, that is actually always 4, right? And 4 feet per second, right? So keep that in your mind later on, we need that, okay? Or you could write down here. And what is our job? Our job is to find the derivative of y with respect to t, right? Not always, only when x is equal to 8. All right, so after we have all of these information, let's try to work this related rate problem. So what do we need to do on the related rate problem? Well, this is what we need to do at the beginning: understand the problem, extract the information, right? What are the variable involved on the problem? We need to write it down. What is the rate of change if we have given? We need to write that down, and all the information that are on our problem, so we can write it down, right? So once we have that, now what is the next step? We need to find the relationship, or we need to, from the given information, we need to either have given the relationship between the x and y, or we need to find our own, we need to find a relationship between the variable from the given problem. So what are the variable involved here? X and y, right? How are they related with each other in our problem? You can see, is there anything like interesting here? Well, you might have noticed here is actually a right angle triangle, right? And then this is x, the base, right? This is adjacent side, which is y, and this is 10, hypotenuse side. So if that is the case, how are these three things related with each other? By the Pythagoras theorem, what can we write down? X square plus y square is equal to square of the 10, right? So this is what we can write down. Nice relationship between x and y. Awesome. So that's what I needed. So this means x square plus y square is equal to 100, right? So this is the relationship between x and y. So on the related problem, when we have the relationship between the variable, what is the next thing we need to do? We need to find the relationship between the rate of change. So that is the main thing here, right? But how do we get the relationship between the rate of change? As you notice that the x and y in our given problem here is actually function of t, because you know that the x is also changing, y is also changing, right? So we have given that here, this is feet per second, so it's changing, so they are actually a function of t. So if that is the case, let's differentiate with respect to t on the both sides. So let's differentiate x square with respect to t, plus let's differentiate y square with respect to t, and also let's differentiate the constant which is on the right hand side with respect to t. So what do we get? Now we know what is the derivative of the 100, right, with respect to t. That is just a constant function, so derivative of that will be 0, right? And in the same way, now let's try to find out what is the derivative of x square with respect to t. Keep in your mind that here is x variable, here is t, but x is actually some not random some variable, x is depending on the time, right? So this is actually, we can think of a function of t. So if that is the case, how do we find the derivative? By using the generalized power rule, because we have a something like function raised to the power something. So let's use that. How do you use that? Bring the power down, 2 is down, x is a function of t, so write that down, subtract the power by 1, so 2 minus 1 is 1, so we don't have to write it down, but times, we need to find the derivative of x with respect to t, so let's write that down. In the similar way, y is a function of t, so when we differentiate with respect to t, use the same idea, bring the power down, write down y as it is, subtract the power by 1, so just 2y, right? But don't forget to now multiply by the derivative of y with respect to t. So now on this step, you can clearly see we have a nice relationship between the rate of change, right? So when we have this relationship between the rate of change, now our goal is to look back again in our problem and then see what do we need to figure out. Our goal is to figure out the derivative of y with respect to t when x equal to 8, right? So let's do that then. Alright, so to do that, let's try to write down all the information that we have so far. So 2 is a constant, write down as it is. Do we know now what is x? When do we need to figure out the rate of change? When x is actually equal to 8, right? So why don't we plug that in over here? So 2 times then 8, right? Do we know what is the rate of change of x with respect to t? Yes, that is always a constant. We have given that, right? It's always 4 feet per second, so we can actually write down that 4 here, okay, plus 2 times, our goal is to now actually write down for y, and then derivative of y with respect to t. That it's okay, because we don't have to know the value of this, because that's the one we are trying to figure out, no problem with that. But if that is the case, we at least need to know what is y. But do we know y here on this information? No. Did we miss something? Well, let's revisit the problem then. Okay, I don't see anything like that, but can you guess what can we do here? We know at least x, right? And then actually we have already developed a relationship between x and y. So if that is the case, when x equal to 8, your goal is to figure out what is y. So can you find that? Well, I think it's very straightforward to work, right? So let's try to work over here. All right, so how do we find this? When x equal to 8, we can just plug that information in here. So we get 8 square plus, and y is unknown, so write down as it is equal to 10 square, which is 100, right? Okay, nice. So y is the only unknown, then we can just solve for this. 100 minus 80 square, which is 80 square is what was that, 64, right? So if that is the case, subtract 64 on the both side, then y square is equal to 100 minus 64 will be 36, right? And then y is equal to positive or negative 6, right? So when you take the square root, let's say we get positive and negative. So are we going to use both of these value? We get the value of y, but we have two value, right? What do we do here? Well, we need to understand what y means. What y mean in our problem, y is actually just the distance from top of the ladder to the bottom of the wall, right? And that has to be, I think, positive, right? So if that is the case, then actually we'll be just taking the positive 6. All right, so let's just take the positive 6 then, and then plug that information in here. Y equal to positive 6, so that is just 6 then. And then derivative of y with respect to t is the unknown. That's what we need to figure out. Or we are almost done. Okay, so since our goal is to find the derivative of y with respect to t, some of you may realize, okay, our job is almost done, right? Not just almost done, it's actually, oh, you see, okay, I know, and after this, how can I do it, right? How can you do it? Well, we can just need to simplify a little bit and then solve for derivative of y with respect to t. So how do you solve this one? What is 2 times 8? 16. 16 times 4 will be 64, right? Okay, plus what is 2 times 6? 2 times 6 is 12. Okay, times derivative of y with respect to t is equal to 0. So how do we isolate derivative of y with respect to t? We first need to subtract 64 on the both side, right? Okay, so let's do that. And when you subtract 64 on the left hand side, 64 minus 64, when you combine, that will be 0. So on the right hand side we'll have negative 64. And now how can you isolate this one, derivative of y with respect to t? We need to divide by 12 on the both side, or you can say multiply by the reciprocal of 12 on the both sides. So when we do that, this will be negative 64 over 12. I think it is done. If you want to simplify, this can be also written as negative 16 over 3, or approximately equal to negative 5.33. Okay, whichever answer format you need it, you can choose, but this is the rate of change of y with respect to t. So if that is the case, what was the question? Our question was to figure out how fast is the top of the ladder sliding. So in that case, we can say the ladder is sliding down, right? Sliding down at a rate of what? At a rate of 16 over 3, right, feet per second. Since I have used the word here, I didn't write down negative 16 over 3 as a rate, because I have already written here sliding down. So the ladder is sliding down at a rate of this one, right? So that's the speed we have to slide down the ladder. The top of the ladder is sliding down in that way, right? So you could still write down maybe more clearly, you could write down the top of the ladder.